This time I will design another doubly reinforced beam section. Again, to tell you, the problem will not tell you it is a singly reinforced beam or doubly reinforced beam. This is my problem. There's a simply supported beam. The factored moment is 300 kPa. The section is given 10 inch by 20 inch, and the reinforcement will be located 3 inch from the bottom. Material is 4000 psi concrete, 60,000 psi steel. Now we have to design the reinforcement. So I already wrote down the steps very briefly. In my previous videos I explained the steps. So here I will go very briefly. So step number 1, we have to calculate the load, but we do not need to because the problem already gave us moment. So step number 2, find factored moment. We need to find it, but the problem made our life simple. It already gave this value. So 300 cube feet. Step number 3, we have to check it is a singly reinforced beam or doubly reinforced beam. How to do it? We need to calculate this value first and go to your appendix table and find rho. If our rho is more than maximum, that means doubly. Okay, let us find this. And this value is typically pound in this unit. So moment 300 cube feet. So 300, we need to make it pound, then times 12. So it will be pound inch divided by P is 0.9, B is 10, and D is 17. What is this value? If I solve it, 300, 12,000, 0.9, 10 divided by 1384. And then find rho. If you go to your appendix table for this material, most probably appendix table 13, if you go there, you will find that this value exceeds the content of this table. That means my rho is more than max. So in this case, my beam is not singly, it's a doubly reinforced beam. So my beam is a doubly reinforced beam. Why? If you go to the table, I'm going now. So if I go to the table, table A13, yes. If you go there, I memorize this because I got this value so many times. Table A13 for 60 KSI steel, 4 KSI concrete, the last value is 912. But I got 1300. So it exceeds the max. So it is doubly. Then what is the step number 4? What is the select rho max? And that value is 0.0181. You can select from this table, or you can go to table A7. You can go to table A7 or A13. Both will give you this value. Okay, so this is done. Then calculate the moment capacity for this reinforcement. For rho max, find EMU by PD square. We already saw that value, 912 in table A13. Now, if I change this material properties, your table number will change, this value will change. Okay, then what is the moment capacity? 912 PBD square. So 912 P is 0.9, B is 10, D square is 17. And this is pound inch unit. Okay, I will divide by 12 divided by 1000 to make it pound feet. Actually, I do not need to make it pound feet. That should be good also, no problem. Whatever you do should be fine. 912, that means whatever unit you use, be consistent. But it's a very big value. This is why sometimes I like to convert it into pound feet. Okay, convert into pound feet so that I can see it better. Divide by 12,000. I got 197. So I got, where to write it? I got 197 cubic feet. If I do this, I can feel better. Easy number, very small number. I can easily feel. My maximum moment is 300, and by providing maximum reinforcement, it can take 197. The balance is 300. So this is 300. This is 197. My leftover is 103. Yeah, 10300 cubic feet is my leftover or excess moment. I need to provide additional reinforcement to carry this. So 103 times 12. Why times 12? Because this value, okay, I'm telling it later. Because this value Fy is 60 ksi inch square. So I need to make it keep inch. So this moment is keep inch. This is ksi. This is d is my 17 and d prime is 3. Why 3? Because the problem told us place your reinforcement here up at 3 inch from this edge. So I will place this reinforcement also at 3 inch to be consistent. This is I use this time 3. In my previous video I used 2.5. But whatever you use is not a problem. This 3 inch will cover my clear cover and stay up. Okay, any other discussion here? No, clean. So 103 times 12 divided by 0.9 divided by 60 divided by 14. I got 1.64. I'm doing very quickly, so I might make any calculation mistake. Excuse me for that. So 1.64. If I see your book, whatever it is, yes, hopefully my calculation is right. Okay, then I'll go to step number 8. Now we have to find our AS prime. How to find it? At first we have to find AS1 Fy divided by 0.85 F times B. What is AS1? AS1 is my reinforcement that I provided here with rho max. So rho max. Then what is my reinforcement here? AX1. So this 0.0181 times B is 10 inch, times D is 17 inch. So again to write here. So AS1 is rho BD. Rho is rho max. What is this reinforcement here? 0.0181 times 10 times D. 3.08 inch square. So here I will write 3.08 inch square times 60 divided by 0.84 times 4. B is 10. So 3.08 times 60 divided by 0.85 divided by 4 divided by 10. So I got 5.44. Beta 1 is 0.85. Beta 1 is 0.85 for this concrete. If I use other concrete, you know how to find beta 1. It is a very earlier discussion. Then if I use this one, I will get 6.4 inch. So A is 5.44, beta 1 is 0.85. If I do this calculation, I will get 6.4. Then I can find my strain in comprehension steel. C minus D prime. What is C? I just found 6.4. So 6.4 here, 6.4 here. D prime, this time I used how much? 3 inch. So 6.4 minus 3 divided by 6.4 times 0.003. I 0.003. I got very small number, 0.00159. 0.00159. Let me check with your book. It's very difficult to find it. Okay, solve it here. Then what is my yield strength? Yield strength means yield stress divided by modulus. What is our yield stress? 60,000 psi. What is our modulus? Always 29,000 ksi. So we will use ksi. So 60 divided by 29,000. And I already memorized this number. This is 0.00207. Because these are very common values. I did it many times. I memorized it. So you can see now, compare. My strain here is less than yield or no? Yes, it is less than yield. That means this is not the case. This is our case. So this is our case. So what I will do, I will erase this, so make our life easy. So our case is this. This time my still compression still is not yielding. So what is my yield stress now? Yield stress is okay. I am writing here to save some space. Stress 0.00159. Whatever I found here times 29,000 ksi. It is 46.2 ksi. Okay, then I can find my compression steel. AS2. What is my AS2? We found somewhere here 1.64. So 1.64. What is Fy? Fy is 60. What is Fs prime? Fs prime is 46.2. Again to tell you, yes, when we did this, we have some limitation here. We discussed it earlier. We can fine tune it, but again, this value is very close to the exact value. So mostly we do not do any fine tuning here. But just to remind you that this calculation is not perfect. There is some limitation. But still that will give us very good answer. 46.2. I got 2.13. 2.13 inch square. Okay, then I will make some room here. Then step number 1, AS equal AS1 plus AS2. Okay, we will do it here. So here our reinforcement will be AS equal AS1 plus AS2. My AS1 how much? Somewhere here. So 3.08. AS2 is 1.64. Let me check one more time. 4.72. Here my reinforcement will be 2.13. AS prime 2.13 inch square. Okay, this is done. Then last step is detailing. Detailing means choose your bar, place it, see the minimum spacing, place your stirrup, then show the drawing in a neat sketch. Those are like detailing. It takes time. I should not do it here. At the same time, it takes time. At the same time, you know how to do. Just give some time, choose your bar, place it, check the minimum reinforcement, place the stirrup, and show the drawing in a very neat sketches. Okay, so I will stop here. Before stopping, anything to discuss? I do not think. Just whatever steps I gave you, just follow step 1 to 10. Then doubly-reinforced beam is very simple. Okay, so in my next video I will discuss more example. Thank you.